Okay, students, we're on page 563, mod 3, topic 2, lesson 3 on sine. We just got into tangent. Now we're doing sine today. Next class, cosine. Okay, then you'll have a quiz. Okay, just remember SOHCAHTOA. That explains all three of them right there. So we just did tangent last time. Tangent equals opposite over adjacent. Today we're doing sine, this first one. So opposite over hypotenuse. Okay. So what they want us to do is quickly do a review of last time. Here it says calculate the value of tangent of h. So h is a reference angle. There's my hypotenuse. Now notice here, they only give me 2 or 3 sides. And remember, tangent is opposite over adjacent. So I need to find that third side. I can either remember my Pythagorean triples, 8, 15, 17, and know it's 15, or you'd have to use Pythagorean theorem. C squared equals a squared plus b squared. And so 17 squared equals 8 squared plus b squared. Since I'm solving for b, I need 289 for 17 squared minus 64. So b squared equals 225. And take the square root of both sides. And you get b equals 15. It would be plus or minus 15, but don't forget you can't have a negative side length, so we only take the positive answer. Okay, so if you don't choose to memorize Pythagorean triples, you have to use Pythagorean theorem. Now it says calculate the measure of angle h. So again, we can, since you've only used quote tangent so far, we would have the tangent of h equals the opposite 8 over 15. And then of course to get rid of tangent, you need to do inverse tangent. So inverse tangent of 8/15 equals measure angle h. Putting in a calculator, inverse tangent of 8/15, 28.1 if we round to the nearest tenth. So h is approximately equal to 28.1 degrees. If I said to the nearest degree, say 28 degrees. Okay, let's go on now. Okay. We're not going to go ahead and do that. Let's see. So sine, as it's telling you, is opposite to the length of the hypotenuse. Sine equals opposite over hypotenuse. So if we talk about angle A, okay, so if we do sine of A, obviously that's my opposite. There's my adjacent, there's my hypotenuse. The sine of A would be BC over over hypotenuse, AB. Okay, if I made B the reference angle, the sine of B opposite AC over the hypotenuse AB. Okay. So that'd be examples of that, and they just had you fill those in. Okay. Cosecant is the next one down. Cosecant is the reciprocal of sine. Okay. Cosecant equals hypotenuse over opposite, the reciprocal, as I just said. Now, so CSC is cosecant. You don't say CSC, you say cosecant. Okay. Now, how do I know, what's a good way to remember that cosecant is the reciprocal of sine? The only way that I'll figure anything out is look at the middle letter. The middle letter is S, and sine starts with an S. Okay, because secant doesn't sound like sine. The only thing is got the same letter, sine and secant. Okay, so that's how I remember that those two are connected. Okay. So they want you to find the sine of 30, 45, and 60. Leave your answers as exact values. Again, that means with radicals, no decimals. So you don't need a calculator. All right, so the sine of 30 is opposite over hypotenuse. So sine of 30 equals 4 over 8. Of course, I reduce that down to 1/2. Okay, here's 60 degrees. So if I use that as my reference angle, then this is the opposite over the hypotenuse. So the sine of 60 is 4 root 3 over 8, so that reduces down to root 3 over 2. And lastly, the sine of 45, opposite over hypotenuse, 8 over 8 root 2, which now simplifies down to 1 root 2, but we know we can't leave it like that. No radicals in the denominator, so we must rationalize it. So I'll say that over and over. All next year in Algebra 2 and Pre-Calc, Calc, etc. And I get root 2 over 2. Okay, those are the exact values. No decimals, you don't put in the calculator. All right, inverse sine. Remember, anytime it's inverse, we are calculating the angle measure. Okay, so as is the measure of acute angle whose sine is x. Okay. Now, it says in triangle ABC over here, the sine of A is 2/5. Remember, sine is opposite over hypotenuse. So 2 over 5 with reference to angle A. Use the inverse sine. So inverse sine to calculate it, opposite over hypotenuse. Okay, so now I put that in the calculator. And get that approximate answer. So inverse sine of 2/5. Inverse sine, second sine of 2 divided by 5. 23.59. Going to the nearest hundredth. Okay. So this is called error analysis, where you try to find where the student made the error. Because the sine of A equals 2/5. That's correct. I can use the sine button on my calculator to determine the sine of 2/5. Is that what you're supposed to do? No. Okay, sine of A equals 2/5. If I'm going to use the sine button is for side lengths. Okay, not for angle measures. Inverse sine, remember, inverse sine is for angle measure. We're trying to find the angle measure of A. So you have to use inverse sine. So he did sine of 2/5, got 0.007. Then I take the inverse of that. Remember, the inverse is that x to the -1 button. He took the inverse of that, determined the measure of angle A, and got 143. Wrong. Okay. Determine the ratio. Remember, that means a fraction for sine of B. So there's our reference angle. So the sine of B equals, I want a ratio or a fraction, and I just stop right there. Opposite over hypotenuse, 11/25. Very simple. Now we're calculating the measure. If we're going to do the measure of an angle, remember it's going to be inverse sine of y. I was going to say that's okay. So angle y is our reference angle. Inverse sine, opposite over hypotenuse. Put in a calculator. That's the exact answer. And then round it. Inverse sine of 5/12. Inverse sine of 5 divided by 12. 24.62 is the approximate answer. Degrees. Okay. This didn't go anywhere. We've done all that we need here. Is there anything more we want to? So as a quick review, the sine ratio is a fraction. Cosecant ratio is also a fraction, where it's the reciprocal 1 over sine, cosecant, the reciprocal of sine. And the inverse sine is to calculate angle measure. Okay, so just remember that if you're ever going to use inverse sine in a calculator, it's calculating angle measure, never side lengths. These are for side lengths. Okay, so if you remember that, you won't blow it and don't know the difference between using sine and inverse sine. Inverse sine, anytime it's inverse, whether it's inverse sine, inverse cosine, or inverse tangent, in a calculator, it's to calculate angle measure every time. All right, that does it.